Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss another question on graph, that is minimize malware spread 1. Right? So in this question we are given a network of n nodes represented as a n cross n adjacency matrix graph, right, where the ith node is directly connected to the jth node if graph of ij is 1. Right? So we are given an adjacency matrix. Right? So we are given a matrix of n cross n size. Right? So if ij is given as 1, this means that the first node is directly connected to the 0th node, right? So in the graph there is a edge between the first and the 0th node if the value in the adjacency matrix is represented as 1, right? So this adjacency matrix is representing our network, right? So next is all the nodes are initially infected by malware. Whenever two nodes are directly connected and at least one of those two nodes is connected by malware, both nodes will be infected by malware. This spread of malware will continue until no more nodes can be infected in this manner, right? So if there is a direct edge between two nodes, right? So initially we are given some nodes which are infected by the malware, right? So let's suppose 0 is infected by the malware. So if graph is like this, right? So 0 is infected by malware, right? So 0 is infected by malware. Since there is a direct edge between 0 and 1, so 1 is also infected by malware, right? Now 1 is infected by malware, there is a direct edge between 1 and 2, so 2 also become infected, right? Now there is a direct edge between 2 and 3, so 3 also becomes infected, right? So initially only 0 is infected. Now from 0 the infection is spread to all the nodes until all the nodes are infected in this manner, right? So all the nodes of this graph are infected by malware in this manner, right, by using these edges, right? So initially we are given some nodes which are initially infected by the malware, right? So m is the final number of nodes infected with malware in the entire network after the spread of malware stop. So we are given a number n. So m is representing the total number of nodes infected by malware in the network, right? So we will have to exactly one node from initial, right? So in the initial, if we are given some nodes, then we can remove exactly one node. For example, 0 and 1 is given in initial, that is 0 and 1 are initially infected by malware. Now we can remove exactly one node from this initial. How? That if removed would minimize m. If multiple nodes could be removed to minimize m, return such that with the smallest index, right? So we have to minimize this value. So we have to select that node by which the m becomes minimum, right? So we have to minimize the total number of nodes infected by the malware infection, right? So we have to find out that by removing which node the spread of malware becomes less, that is number of nodes infected by malware becomes less, right? So if multiple nodes are used for this purpose, that is by using 0, also the m remains same. By removing 1, also the m remains same. Then in that case we have to return the node with which is present at the smallest index, right? So return that node. If a node was removed from the initial list of infected, it might be still infected later due to the malware spread. Now what does this line means? For example, we are given a network like this: 0, 1, 2, 3, 4, right? So let's say we are given this network and initially 1 and 4 are infected by malware. Then because of 0, let's take 0 here, right? So because of 0, 1 will infected. Because of 1, 2 will infected. Because of 2, 3 will infected. 4 is already infected, right? So it is given that if a node was removed from the niche, it might be still be infected. So if 0 is removed from this node, right, from the initial node, right, now 0 can still be infected by the malware spread. How? So if I remove 0 from the initial node, then it is possible that 0 may be infected by malware due to 4. Why? Because 4 is present here, right? So 4 spread the infection to 2, 2 spread the infection to 1, 1 spreads the infection again to 0, so 0 again becomes infected, right? So if I remove 0 from initial node, then 0 again can be infected by some other node, right? So this is the question that we have to find out, that to remove which node, after removing which node the number of nodes infected by malware becomes less, right? So let's take an example. Let's remove this. I hope you understand the question. So let's suppose we are given this network, right? So we are given this network, right? So let's say we are given the initial as 2, 6, 9 and 11, right? So the number of nodes infected by these nodes are, now infection spreads from 0 to 1, from 1 to 3, from 3 to 4, from 4 to 5, 6 is already infected. From 9 infection spreads to 8, from 8 to 7. Now from 11 infection spreads to 10, right? So total 11 nodes are infected by malware, right? Now let's remove 2 from the initial node. Now 2 becomes uninfected, right? Right, now 2 becomes uninfected. Why? Because now I remove 2 from the initial, right? So 2 becomes uninfected. Now because of 2, 1 also becomes uninfected, but 1 is also infected by 6, right? Infection is spread to this, infection is spread to this, infection is spread to this, infection is spread to 1, and again infection is spread to 2, right? So by removing 2, none of the node becomes uninfected, right? So there is no any advantage to remove 2 from this, right? So let's take the next node, that is 6, right? So let's remove 6. Now if I remove 6, then because of 6 it may be possible that 4 becomes uninfected, right? But 2 is infected here, so because of 2, 4 again become infected and 6 again become infected, right? So there is no any advantage to remove 6 also, right? Next is if I remove 9. Now if I remove 9 from the initial, now 9 becomes uninfected. Because of 9, 8 also becomes uninfected. Because of 8, 7 also become uninfected. So previously total number of uninfected infected nodes are 11. Now 3 nodes become uninfected. So now the count become 8, right? Right. So now the count becomes 8. So if I remove 9, then total 8 nodes are now infected, right? Now if I remove 11, now because of 11, 10 becomes uninfected, right? So total 2 nodes become uninfected. Previously the infected nodes are 11, now 2 becomes uninfected, so total are 9. So if I remove 11 from the nodes, 9 nodes become uninfected from the malware effect, right? So I have to choose the minimum value, right? So if I choose 8, if I choose 9, then 8 nodes become uninfected. If I choose 11, then 9 nodes becomes infected, right? So I choose 9, right? So I choose to remove 9 from this network in order to minimize the number of nodes infected by the malware spread, right? So 9 is the answer, right? So we have to return this answer, that is which node is to be removed, which is node proves to be beneficial if removed from the initial, such that the total number of infected nodes become less, right? Such that our m becomes less, right? Now how can we achieve this? Now you can see that if here if I make the groups of nodes, right? So this is one group, this is another, and this is another, right? So if I find the union function, if I find the union of this graph, the given network, then this graph will be divided into groups, right? Also the union function will give me the size of each group, right? The size of each group, right? So if I am able to find the size of each group, then in a particular group I can check that on the removal of one node, if the size of this group is greater than this group, then the removal of node from this group is beneficial for me than this group, right? So if I remove the infected node from a bigger group, then the number of nodes which are now infected becomes less. So we want that only, right? So we will firstly find the union function of the given network such that we can divide our graph into groups, and then we will find we will find the size of each group. Then we will choose that node the size of whose group is maximum, right? Such that minimum number of nodes are now infected, right? So we have to choose that group, that node, this size of whose group is maximum, right? So let's now move to the code part, right? So firstly we will have to find the union of the graph, right? So we have to move in the graph. Let's store the size of the graph in some variable length, right? Now in order to find the union function, we need two more functions, that are the find function and the merge function, right? So in order to find the union, we need two array. Let's declare them global. One will be our parent array and one will be our size array. Why? Because we need size of each group, right? One will be our size array, right? So let's initialize them here. Size will be of size n and parent will also be of size n, right? Next is if there is a edge between the two nodes. If the graph of two nodes is 1, right? If 1 is given in the adjacency matrix, this means that there is a edge present between the two nodes, right? So if the edge is present between I and j, then find the parent of I. We have to write the find function here. Find the parent of I and find the parent of j, right? Fine. Right now check that if parent of both are not equal, that is both of them are belong to different group, then merge these two. Merge parent 1 and parent 2, right? So this for loop this for loop is going to find the groups of the graph, that is to divide the group into the graph and also find the size of each group, right? Now we have to write the find and the merge function, right? So let's first write the find function. So find the static, the return type is int. So find the parent of a node x, right? So if parent of x is the node itself, then return that node, else find the parent of that node. Parent of its ancestor, right? So fill the value in the parent array and return that value, right? Also we have to initialize these two array, that is the size and the parent array, right? So let's initialize them here. So the parent of initially is the node itself. So parent of I is I, and the initially the size of all the nodes is 1. The node itself is present, right? So the find function is completed. Now let me write the merge function, right? So the return type of merge function is void only, right? So void merge. Let's write them as leader of x and leader of y, right? So normally we don't merge the groups on the basis of size, but here we are going to use this. So let's use the size of the nodes, right? The size of the group. If size of leader of x is greater than size of leader of y, then parent of leader of y is now leader of x, and also increase the size of leader of x, the size of this group by the size of this group, right? Else reverse of this, that is parent of leader of x is leader of y now, and increase the size of the y group, size of leader of y, size of leader of x, right? So this is all about the merge function. Now this will give us the group, this will give us these groups, right? These groups. Now here we have to take into our notice one more thing, that is if two infected nodes are present in the same group. For example, in this case 2 and 6 are present in the same group, right? 2 and 6. So if I remove 2 from this group, then none of the changes will happen, none of the node will become uninfected. Why? Because the nodes becomes infected again due to this 6, right? If I remove 6, then also none of the node will become uninfected. Why? Because nodes will become infected again using, because of this 2, right? So if more than more than one infected node is present in any of the group, then we can't remove that node, because it will not help us to minimize the number of infected nodes, right? So we will create an infected array where we will write the number of infected nodes present in each group, right? So let's take the infected array here. The maximum size can be infected, right? So the maximum size can be n, right? So we'll move in the initial, given initial array, initial, right? So firstly find the parent of e and mark it and increment its value, right? So it is possible that the initial, two of the initials may belong to the same group, right? Two of the initials may belong to the, for example, for 2 and 6 they are belonging to the group 1, so the value becomes 2. Now if the value is 2 that is greater than 1, then we don't need to remove that node, right? So if I remove 2 from this, then it is not going to represent, it is not going to change the number of infected nodes. But if I remove 7, then it will change, right? So if I ignore these values, that is if the number of nodes are present are more than 1, right? So here we will do this. Next, let's find our answer. Let's mark them to -1 and also the size to -1, right? Move in the initial array, right? So first of all find the parent of e. So if the infected of parent, that is the infected of par is equal to 1, right? So I'll choose to remove this node only if it is the only infected node present in its group, right? And also the size of its group should be maximum. Why? Because if I remove, if let's suppose 6 is not present here, if I remove 2 from this node, the size of this group is maximum. So if I remove this node, then it will the number of nodes which remain infected will be minimum, right? So I'll choose the group which is having the minimum size and in which only one infected node is present, right? Sorry, I will choose the group with maximum size because I want to make maximum nodes to be uninfected, right? So I'll choose the group if the size of that parent, the size of that group is greater than or equal to max size, right? Now there is a more condition also, that is if the size is equal to the max size, then in that case we are given that we have to select the minimum value. So answer will be what? The minimum of our answer and the node, right? otherwise answer is the node, right? So now our max size is what? Update our max size to the size of the group, right? So this is done, right? Next step is, in the end, if we don't receive any answer, if answer is still -1, then in that case we have to choose the smallest index, right? So choose the min, right? So for in the given initial array, choose the value with smallest index, right? Answer is what? Sorry, minimum. Let's name it as minimum. Minimum is what? The minimum value, the minimum of min and e, right? So return min in this case if we are unable to find any answer, otherwise return the answer that we found, right? So this is the code, right? So this is our code. We are doing what? That we are finding the union of the two union function of the given network, that is we are grouping the graph into the connected components, into connected groups, and also we are finding the size of that group. Here we are finding that if more than one infected node is present in a group, then there is no need to remove that node. Why? Because if I remove this node, then the other infected node will become again make the entire group infected, right? So I'll ignore these nodes. So I am storing the number of infected nodes in a particular group in this array, in this infected array. Next, I am finding the answer. I will choose that group which is having the maximum size, because that will help me to make the maximum number of nodes uninfected, right? So here it is a special case that if the size is equal, then we have to return the minimum index, the smallest index, and also that node must be the only infected node present in that group, right? So here write else here, right? This max size is in this if statement only, right? We are updating the max size, right? Next is, if we are unable to find any answer, then return the smallest index present in the smallest node present in the initial array, otherwise return that answer, right? So this question is not updated in our portal, right? So it will not run. So I took the input here only. So I took the input here only for one of the adjacency matrix and initial array. So let's run this, and then we will check the output. There are two compilation errors at line number 40 and 40. At line number 40, size of I is equal to 1, right? One more error at line number 14 and 44. So let's check. There is some compilation error. Oh, here it's equal to 44. Here we are checking that if the value is equal to 1, right? So we are getting the answer as 0, right? So let's make a dry run on this input, right? So the graph is 0 as 1 1, given as 1 1 0 1 1 0 and 0 0 1, right? So the adjacency matrix is this, that is 1 1 0 1 1 0 0 0 1, and initial is this, right? So this is our default input, this is our graph, right? Now it is showing that between 0 and 1, 0 1 2 0 1 2, right? So three nodes are present. There is a direct edge between 0 and 0. So since this is an undirected graph, so the self edge is always present, right? So there is a direct edge between, this one is showing that there is an edge between 0 and 1. So there is an edge between 0 and 1, and also there is an edge between 1 and 0. So this is the same, right? So these are the self loops, right? So initially 0 and 1 are infected. So 0 and 1 are infected. So if I remove 0 from this, then total number of infected nodes are 2, right? So if I remove 0 from this, then 0 again become infected due to 1. If I remove 1 from this, right, if I remove 1 from this, then 1 again became infected due to 0. So I can't remove any of the node. No, none of the node is giving me any benefit. None of the removal of any of the nodes is not giving me any benefit. So I will choose the node with the smallest index. So the answer should be 0, right? So it is giving me correct answer, that is 0. So since this question is not updated on our portal, so you guys try this question, because the code is perfectly correct. So we will update the test cases of and the input and handle the input and output for this question, right? But the code is perfectly correct, right? So you can try this code. So I hope the question is clear to you, right? So if you like the content, then give a like to this video. Thank you for watching.